we are going to discuss the addressing modes of 386 processor. The end of the sessions, we are able to explain the operation of each data addressing modes, use the data addressing modes to form the assembly language statements, explain the operation of each program memory addressing modes, use the program memory addressing modes to form the assembly and machine level language statements. Generally, whenever we want to write the programs in the ASM, that is the assembly language statements, we need the two basic requirements, that is the different addressing modes, in which we are specifies in which way the data is transferred from one memory segment to another memory segments, or one memory segment to processor and vice versa, and another is the instruction set. So at the end of this, we are able to explain the operation of each data addressing modes, the data addressing modes to form the assembly level language statements, explain the operation of each program memory addressing mode, use the program memory addressing modes to form the assembly and machine level language statement. These are the different data addressing modes, register addressing modes, immediate addressing modes, and the direct addressing modes. In the register addressing modes, generally source and destinations, we prefer both the registers, where in the immediate addressing modes, immediate data are represented. In the direct addressing modes, we specify any array in the instructions. Here, the register addressing modes, immediate addressing modes, and direct addressing modes are differentiated on the basis of their examples. Generally, we need some instructions for transferring the data. Here, move is a simple instruction which is used for transferring the data. The method of transferring the data is this way. There is source is there and the destination is there. Source is there at the right hand side, whereas the destination is present in the left hand side. You can see this, the movement of data from the right to left positions. And move instructions is used for transferring the data. The most common form of the data addressing is the ones the register names learns easiest to apply. The microprocessor contains these 8-bit register names used with the register addressing AH, AL, BH, BL, CS, CL, DH, and DL. 16-bit register names AX, BH, CS, DX, SP, BP, SI, and DL. Data addressing modes: base plus index addressing modes, register relative addressing modes, base relative plus index addressing modes, and the scale based index addressing modes. Some little bit changes are based on the in all these addressing modes. It will be verified on the examples given in this slide. Register addressing mode, it is the most common and it is the easiest to apply. Microprocessor contains 8-bit, 16-bit, and 32-bit register. Never mix 8-bit register with a 16-bit register, 16-bit register with a 32-bit register, etc. because this result in an error when assembled. In 386 and above, extended 32-bit registers names and extended AX, extended BX, and so on. Important for this instruction to use registers that are the same size. Never mix the 8-bit with a 16-bit registers and 8-bit or the 16-bit register with a 32-bit register. This is not allowed by the microprocessor, resulting in an error with assembly. The term immediate implies that the data immediately follow the hexadecimal code in the memory. Immediate are constant data. The move immediate instruction transfer a copy of immediate data into the register or immediate locations. There are two basic forms of direct data addressing. Direct addressing, which applies to the move between the memory locations AL, AX, and X. Displacement addressing, which applies to almost any instruction. The instruction set direct addressing move AL, data. Register indirect addressing moves allow data to be addressed at any memory locations through an offset address in any of the following register: BP, BS, DR, and SI. Move AX, BX. So since bracket is specified, that is the indirect addressing modes. In the bracket, it is defined that BX is contained in the memory locations. Data segment is used by default with the registers indirect addressings or any other addressing modes that use BX, DR, or SI to address the memory. Register indirect addressing modes. Sometimes indirect addressings require specifying the size of the data with a special assembly directives, byte PTR, word PTR, or the D-word PTR. This indicates the size of memory data addressed by the memory pointer indicate. Indirect addressings allows the programs to refer to a tabular data located in the memory systems. The data in the segments of memory are addressed by adding the displacement to the content of the base or the index register. The displacements can be number added to the registers within this bracket, as in the move. This is one of the examples, or it can be displacement separated from the registers, as in the move AL, SL -1. This mode of open address is a two-dimensions array of memory that is the least used addressing modes, too complex for frequent use in the program. Addressing arrays with the base related plus index addressings. The displacements address the files. The base register is the record. The index register address is the element of the record. This type of addressing is unique to 386 Pentium Pro. Program memory addressing modes. Program addressing modes consist of three distinct from direct, relative, and indirects. We are only relative jump and call instructions contain either 8-bit or 16-bit displacement allow to forward the memory reference to the. It is not possible to cover all all addressing modes within the 5 or 6 minutes recording. So we are trying to cover the maximum addressing mode. Thank you.